In this section, we are going to talk about spanning tree stability mechanisms. Let's take a look to the spanning tree protocol toolkit first. These are the tools needed to manage STP better, and their main role is providing a faster convergence for the STP protocol. And they are Uplink Fest, BackboneFast, and the PortFast features. Let's start with the Uplink Fest first. Uplink Fest allows uplink to be transferred to other link on access switch quickly, and that's a Cisco specific feature. For example, when a problem occurs in the root port, the port in the lowest cost value is immediately replaced by the root port. In a total of 1 second, the link is returned to normal. The second feature is the BackboneFast, and which allows STP to quickly converge when STP changes on core or distribution switch. And that's also Cisco specific feature. And BackboneFast is meant to resolve a connection failure on the backbone actually. By using this, if a switch receives a root BPDU with the sending switch's address as the root, it will know it has a broken link. The receiving switch can send then out a RLQ, which means root link query, to see if it still has root itself. If it gets a response to this, it can inform the offending switch, and the transition will occur faster than the listening plus learning times, which is 30 seconds by default. And the third feature is the PortFast, which allows access ports to transit in the forwarding state directly from blocking states. And here is an important point when you are using PortFast. PortFast is not used in the trunk ports, guys. You need to use the PortFast in just for the access ports. And the configuration for the PortFast is pretty simple, and that's just spanning tree and PortFast, but you need to use this under the access port interfaces. BPDUGuard feature protects the integrity of the ports that are PortFast activated, and that's the important point. The PortFast activated, please keep in mind that if a BPDU packet is received from an access port that has PortFast enabled, the port is error disabled. The error disabled mode port is a shutdown port and can be reactivated with just using shut and no shut commands together. First you need to shut, then you need to no shut the error disabled port to make it active again. BPDUGuard can be activated under interface or globally. As you can see that if you want to activate it under interface mode, you can use spanning tree BPDUGuard enable command. But if you want to globally enable it, you can use spanning tree PortFast BPDUGuard default command. BPDU packets are sent even from PortFast enabled ports. BPDUFilter is used to prevent this. The BPDUFilter can be configured globally or under the port like BPDUGuard 2. When configured under port like this, spanning tree BPDUFilter enable command, BPDUs are not sent and all BPDUs received are ignored. When you globally enable it like this, spanning tree PortFast BPDUFilter default, it affects all PortFast enabled ports that have not been configured for BPDUFilter. If a BPDU is detected, the port loses its PortFast status and STP continues to send and receive BPDU packets as it does at other ports. And let's take a look to the RootGuard feature too. The result of connecting a misconfigured switch to the network can change your root bridge. However, since the root bridge is a very basic and the important part of your network, you must ensure that it never changes. And that's why RootGuard is developed. The RootGuard forces an interface to be the designated port to prevent other nearby switches from becoming root bridges. If the switch receives a superior STP BPDU packet from a RootGuard-enabled port, the switch will stop transmitting traffic from that port, and it's recommended that RootGuard to be activated on all access ports. For example, if an attacker wants to plug in a switch and wants to become a root bridge for your network, and RootGuard detects it and blocks the traffic. Let's take a look to the LoopGuard feature now. If you used fiber cabling, guys, you may have noticed that there are different connectors for transmitting and receiving the traffic. If one of the cables send or receive does not send or receive a packet, a one-way connection error occurs, and this may cause a spanning tree loop. There are two protocols that overcome this problem. The first one is LoopGuard, and the second protocol is unidirectional link detect. That's the UDLD. Assume that TX fiber connector of the switch 3 towards switch 1 is torn by the dozer. In this case, switch 3 cannot send BPDU packets to switch 2, and since switch 2 does not receive BPDU packets, the port in alternate state will transit into forwarding state and a one-way loop will occur. LoopGuard takes place when no BPDUs are received from non-designated ports and takes the port to STP loop inconsistent mode and blocks traffic on that segment. Here's how we can configure the LoopGuard too. We are going to interface mode by typing interface, for example, the name of the interface, that's Ethernet 00 for this example, and we type spanning tree guard loop, and which enables LoopGuard on a per interface basis. If we type spanning tree LoopGuard default on the config mode, that enables LoopGuard globally on all 4 point-to-point links. UDLD also works with a similar logic to LoopGuard, and UDLD is a layer 2 protocol that simply behaves like a keep-alive mechanism. UDLD configured interfaces send UDLD packets to the point-to-point port on the other end and receive UDLD echo packets from the opposite sides. They send UDLD and the other guy is sending a UDLD echo back. If the answer to the UDLD packet does not return, this guy, UDLD gets that there's a problem on the link and takes action. UDLD works in 2 modes, and they are normal mode and aggressive mode. In the normal mode, UDLD identifies a problem and marks the problematic interface as in an unspecified state and generates a syslog message about it. But in the aggressive mode, when there is a problem, the switch starts to check whether the link is up, and it generates 8 messages in total for this one. If none of these messages return a response, the port is taken to the error disabled mode and blocked. Here's the configuration of the UDLD 2. In the global config mode, we can use UDLD enable or aggressive. Or if you want to configure it under interface, we can use UDLD port aggressive. We can verify the configuration by using show UDLD command. And if you want to reset all interfaces that were shut down by UDLD, we can use the UDLD reset command. And the last thing we are going to talk about is Flexlinks. Flexlinks are a pair of layer 2 ports that are configured to be an alternative to another interface. Flexlinks provide link level redundancy as an alternate to STP. STP is automatically disabled on the Flexlinks and failover occurs in as little as 50 milliseconds. To configure Flexlinks, example, we can go into the Fast Ethernet 01 first, and we use switchboard backup interface, and we define the Fast Ethernet 02 as the backup interface. And to verify the configuration, we are using show interface switchboard backup command.